Welcome back to my series on Mastering GenAI for MLflow. And today we're on our 6th episode. And today we're going to talk about framework integrations with MLflow. One of the beauty about MLflow is that you can actually use over 30 different integrations of open source building agent frameworks with MLflow. In other words, if you actually have a use case that requires to use any of these open source agent building frameworks, you can actually use that with MLflow, and MLflow will trace it, and you can actually use evaluations with MLflow. So today we're going to concentrate on a couple of those common frameworks, such as LangChain, that allows you to build chains and workflows. We're going to use LlamaIndex to create a particular RAG, and then we're going to see how we can actually use LangGraph to build sort of a routing mechanism or multi-agent workflow in your use case. So based on that, let's get actually started. Here's my sort of quick comparison metrics. Obviously, this is a bit opinionated. You actually have over here where I actually have the tracing. If I'm doing a use case that actually requires me to do very simple calls to LLM, I can just use OpenAI along with the OpenAI SDK. If I want to build sort of a sequence of workflows that requires me to execute things in a sequential manner, I can use LangChain operators to do that. If I have a more complicated agent and routing mechanism where I actually have a use case where I have a supervisor that delegates based on what query is posted to that, I can use LangGraph. And if I want to build a document question and answer RAG, I can actually use the LlamaIndex. All of these provide abstractions and primitives for you to be able to build that using, and then having the ability for the MLflow to automatically actually trace them. So let's get actually started with our environment. I'm going to go ahead and set up my environment. I already ran this prematurely, so that way we don't waste time waiting for it to actually finish. So once I set up my environment, I have my MLflow open client that I'm actually using. So let's start with our first LangChain framework. And this is going to be a very simple chain that allows me to take an input using a particular prompt, call that particular prompt a query to my LLM, and then get the output. And this is going to be somehow using two of the primitives that LangChain gives you as an abstraction. One is called ChatPromptTemplate, and the other one is called StringOutputParser. So that's how we can actually use those two. So what I'm doing is actually I'm building a very simple chain where I'm using the static class primitive called ChatPromptTemplate, giving it a template as the name suggests, where I'm providing the instructions to the LLM. You are a particular role, and role is going to be substituted at the time of invocation. And here's the answer to the question I want you to reply to me. I'll create my LLM object based on what provider that I'm using. And this is really the core of this particular LangChain expression language, where I'm chaining those 2 or 3 operations in a sequence where the prompt is fed to the LLM and the output of the LLM is actually fed to the StringOutputParser. So it takes the response coming back from the LangChain's call and then present that to the user in a digestible manner. And when I do the invocation over here, what happens over here is the prompt will automatically substitute the role and the question in this particular template they actually seen. So very simple high-level primitives that allow you to do that. And when I invoke this chain, what's going to happen is that chain is going to be executed sequentially. So as you can see, I have my short answer over here, and I got my key differences between the OpenAI and LangChain as a way for me to be able to actually use that. And if I go to my MLflow trace, you can actually see here that my chain was executed in that particular manner. This is the top level root chain. It actually invoked my chain template, and then that invoked further did the chat OpenAI with the completions, and then the output of that went to string output parsers. You can see these are the 2 chain operations that are executed. If I look at the chain operator, you can see what my input was, role and question, and the output is what actually came back. I can look at my string output parser, and it got the short answer, and it actually returned that. It's a very simple way to sort of use these particular LangChain operations in a sequential manner, very easy, and trace that at the same time. Let's go to a little more complex chain of operations, which would be most likely what you're going to be doing, right? So over here I have 2 big chains that I'm actually stringing them together. One is I'm going to generate a topic whereby I'm creating a topic promptlet saying, generate a particular technical topic given this particular domain. And this domain is going to be substituted at the time of invocation. And once I get that particular domain topic, I'm going to now create a topic chain where this is going to be my first chain that's going to be executed. And then the second chain is that once you're actually given a particular output prompt, to create a 3-point outline based on the topic. And this topic is going to be something that's going to be returned by the first chain. And then this is where I'm actually stringing those them together. So I have my output chain, which takes the output prompt, goes to the LLM, and then returns the output, and then parses the output. And this is going to be now my final execution of the 2 steps happening in a sequential manner, where I am sending in the domain, and I'll get my topic, and then this topic is actually fed into the second chain, which is going to go ahead and create my outline. So 2 chains of operations using high-level primitives such as ChatPromptTemplate, and boom, you string them together using the pipeline operator, and you execute them using the object that you create with the invoke, substituting the variables you actually need, and you get your output. So here we are. We actually have our LangChain's example number 2. We provided the topic's title as AM operations, and here is the outline, proposed outline we actually got from this second chain of that particular output. And you can actually see I have 2 sequence operations. This is my first chain. This was a runnable sequence that invoked the ChatPromptlet, which then further invoked the LLM output, and then that output actually went to my stringer output. The second one was the topic one, which actually got the same thing, actually have a topic that was given to it, and then it actually go ahead and created a particular 3-point outline. Very simple way to actually use LangChain as a way to create a sequence of operations you actually want. Okay. Let's go now next to the next one, which is our LlamaIndex. So quick summary on LangChain is it has these abstractions which you can actually use as the reusable components. So for example, we saw that in the prompt template. You can actually reuse those elsewhere. You can actually create multiple chains that you actually have typically in a workflow, and those will actually happen in a sequential manner. And agents, you can actually use agents to build these particular patterns where you can use tools such as parsing that come with the LangChain. Our next integration is LlamaIndex. Now, as the name suggests, LlamaIndex is really a documentation, sort of a RAG indexing way to actually do that. And for simplicity, what we're going to do over here is we're going to go ahead and create our LLM that it's going to use. But since I'm using OpenAI, it's going to use the OpenAI embedding model, because I need to embed those documents as vector or floating points so I can actually create an index. For the sake of clarity and for the sake of simplicity, I'm just using some inline document objects that I'm actually creating. Those are the objects that we're going to index, and those are the objects we're going to pass on to LlamaIndex to go ahead and create that an in-memory vector index. In production or in real use case, you would actually create these documents either reading some text files or reading some PDFs or reading some HTML files, where you could be using some chunking strategy to actually go in and index those documents. So over here, we're just going to strictly take that list of documents that we have, and we've created this LlamaIndex object called document, and this is what the text looks like. This particular thing is going to go ahead and create a vector index for us, and this is going to be in memory. Normally, this could be stored on a file system or on a vector store of your index. Once we actually get an index, we're going to use this index to create a query engine. And that query engine now is going to take a query that you're actually asking anything to deal with the documents. It's going to create embeddings for it, and it's going to send it to the query index to get the most documents that actually match that embeddings. And we're going to use, I think the LlamaIndex actually uses cosine similarity. So I just ran this ahead of time because the indexing takes a little bit. So as you can see that he actually went and created this particular index. I have a query that we're going to look what it looks like. What are the tracing capabilities does MLflow have? And it will look at that particular index to do that. It actually gave an answer. MLflow tracing captures the complete execution of all those. We've been actually seeing that. But the important thing is actually you can see how the query was actually executed. So here I actually have my query actually went and created the vector index, and then it actually created embeddings for each of these text index. And it actually went through this entire sequence of operations in order to actually answer my query. So LlamaIndex is actually a good way to create your document. It's actually going to use this query engine to take this particular query, create embedding for it, and then send it to the query engine to get the response. Very simple way to actually do that. And if you see, if I actually go down here into my experiments, I can see the query that I actually sent, which actually invoked the vector index. And if I look at the timeline, this is the entire chain of operations that actually was captured by MLflow. And you can look at the input and output of these particular trace. I can see what was sent, what was returned. If I look at my embeddings, I can actually look at my embeddings to see what was returned. And these are all the embeddings that the text embedding Ada OpenAI actually created on those documents and stored into the vector index. So this is sort of a good way for you to use LlamaIndex with the OpenAI and using MLflow to trace all the operations that actually happen, so you get actually good visibility into how you can actually integrate those with MLflow. Okay, the next thing we're going to do is now the LangGraph framework. Now, if you have a use case where you actually want to have a hierarchical supervisor sort of sub-agents or routing mechanism where you actually have a customer triage graph flow you actually want to create, where you're going to have one agent that actually takes the LLM and picks a particular category and then classifies what are you asking. And based on that, it's going to go ahead and route either to handle a billing, or it's going to handle technical support question, depending on what the query was, or if it's a general inquiry, it's going to send you the building and then finally return you the answer. So this is sort of a good way for you to use a LangGraph to create this particular workflow in your use case. So what we're going to do is we're going to use LangGraph to actually create this particular invocation flow that we actually want. We're going to start that by classifying the query that comes in, and is going to go ahead and send it to the appropriate handler, which is going to go ahead and answer that particular question and return back the response. And one of the important things about in this particular LangGraph is that it actually gives you all this particular creative, such as customer service state, that is shared among all this particular node. So think of a way for LangGraph to be able to actually build these individual nodes and then pass messages using this particular class instance called customer service state. So let's how we do that. We're actually going to create our customer service state that actually is a type dictionary, and it's going to get three particular variable: message, which is going to be the query that's going to receive, the category, which is going to be filled out by the classify node, and then the response that's going to be returned by whoever each is handler. So go ahead and let's create this particular classify node, and you can think of it this like a sub-agent that's going to classify that particular query. So we're actually creating a particular prompt using the LangChain's chain prompt and giving it what its role is. So you are a customer service triage agent, classify any one of these particular queries that actually come in, and then just reply in one word, whether this was tech support, billing, or customer. So this is the way we can actually route to the appropriate handler. And we're going to go ahead and create this particular first LangChain object called chain, where we actually give this particular prompt, and we're going to invoke this particular prompt. And when the prompt comes in, when the response comes in from this particular chain of operation, we'll get one of those three strings. And based on that, we're going to use the appropriate category where this is going to be used. So we have a function called handling bill that actually now has a prompt. And our prompt is, you're a billing technical specialist, help the customer with the billing issue. And then that's where the message is going to be posted in. Here's the customer message. Now we're going to create a prompt chain for that one. And when we invoke that, the response will come back, will be the response for that particular query. And our third node is the technical support. So this old code over here is actually creating this particular hierarchical way to go ahead and create those particular nodes in that particular manner. And routing is a way for it to actually take this particular handler and then invoke these particular functions that we actually have. This is the way we actually build the particular graph. So we're going to add the node classify. We're going to give a function that's going to be invoked when this particular routing is sent. And these are the builder nodes. When we actually build all these particular nodes, we go ahead and compile this. And then now we actually have an entire LangGraph built in, reflecting this particular diagram over here as of a graph. So we're going to go ahead and do this, compile this, run it. And once we actually run this particular app over here is an entire builder, and we're going to go ahead and invoke those. And when you go and invoke this particular message, we actually querying with three particular messages here. We're asking, I was charged twice for my subscription this month. The second message we're going to query is the app crashes whenever I try to export a particular report. And the third one is, can you explain the difference between the Pro and Explain plan? So these are the three distinct queries that we're going to do. The classifier or the router is going to go and send those particular queries to the appropriate handler, and the appropriate handler is going to make a call to the LLM to get the particular response, and we're going to display that. So here we are. Our first message was, I was charged twice for my subscription this month. Right. The category was classified as a billing, and then we got sent to the billing handler to do that. And the response we get is, I'm sorry about that. I can help, blah, 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 blah. So this is what we actually get from the response by the handler. The second message was that my app crashes whenever I try to export a report. And this seemed like that it's going to be something that the tech support can handle it. So the classifier routed that to the tech support handler, and we got a response from our tech support that actually asks furthermore questions how we can actually do that. And then finally, we actually have a third message that says, well, can you explain the difference between Pro and Enterprise plans? And then that is sort of a customer query. It doesn't fit in the billing, nor does it fit in tech support. So the classified was the customer query, and then it actually go ahead and do that. So what we actually see was the appropriate billing, appropriate classification of these categories, and being sent to the appropriate node over here for handling the billing, for handling the tech support, and handling the customer inquiry. And this is all done by LangGraph. And when we actually use that with MLflow, we actually handling and capturing the entire input output of these. So we can see we have three traces over here. The first one is the LangGraph, which classified that, and it classified to be a handle billing. So it actually sent to the particular handle billing, and that's, we can actually see I was charged with my message, and the output came back from the particular LLM. The second query was my app crashes whenever I try to report, and this now was classified as a tech support, and you can see it actually went appropriately to the tech support, and it actually ran that particular query to get the output for that. And our final one was the query was classified this category as a customer inquiry. You can see that. And it went to the customer inquiry support to actually take that particular query and respond to that. So this was a way to illustrate you can actually use LangGraph to build a routing complex agent workload or multi-agent system where you can actually use the MLflow to trace it, so you can actually have an idea of what's happening behind the scenes. And over here, we captured all those traces automatically. So the strength of this particular LangGraph is that if you have a stateful graphs where you want to share the state flows and you want to use the state you can use type dictionary in that particular class to share the particular state. If you have conditional routing based on the query, then you can actually use LangGraph to do that. You can actually have cycles and loop within that to do further iterative refinement. And then this, using MLflow tracing ability, you can actually get a quite visibility into actually what's going on. So just to wrap this up, best practices for using what particular framework is up to you. It depends on your use case. If you actually have very simple queries that you actually want to use, you can use OpenAI for that. Use structured prompts, implement sort of retry logic. Those are some of the best practices. If you're using LangChain, then use the chain operators, the operator to do that. Leverage the built-in components such as prompt template and such as invoke. You can use async if you actually want to wait for certain operations to happen asynchronously. And LangGraph is probably one of the best ways you can actually build a complex workflow where you actually require some sort of routing or some sort of supervisor that routes that. And in all cases, use the MLflow library to autolog. And then if you're actually building a lag index, you can actually use LlamaIndex for that. So takeaways here, all frameworks are automatically traced by MLflow. Choose the one that best appropriate suits for you. LangChain is good for building sort of a sequence of chain of operations, or LangGraphs can be used for stateful and branching. Or if you actually have some sort of a loop, you can actually use that. And LlamaIndex is actually a good way to do some heavy document indexing. So thanks a lot for joining, and hope to see you in the next video.